So in this example, we look at how we can use algebra tiles to show the multiplication of this binomial, x minus 3 times 2x plus 1. And one thing you have to remember about the algebra tiles, well, a few things. We have three different shaped algebra tiles: big squares, rectangles, and small squares. And those areas of each of those things represent something. So if I just blow this up really quickly, our big squares are represented by, or are, what we call x squareds. And the reason they're x squareds is because this dimension and this dimension are the same, both by x, which means the area in here would be x times x, or x squared. Our rectangles, similarly, this dimension, as with the x squared, has a dimension of x. But this dimension here, the width of this is just a 1. So it's just 1x. So these rectangles have an area of x. And then our tiny little squares have dimensions 1 by 1, giving us a little area of 1 for the tiny squares. So it's those dimensions we have to keep in mind when we're using algebra tiles to show expansion of polynomials. So here we have this binomial multiplication, x minus 3 times x plus 1. Remember, the different colors of the tiles represent positive or negative. So we have the darker shaded ones representing positive values, and the lighter shaded ones, this one, and this one, representing negative values. Okay, remember the rules of positive times a negative, negative times a positive, those all are going to apply when we're looking at algebra tiles. So here we have x, this x rectangle, here let me label this x rectangle, and this is an x rectangle, and this is an x rectangle. This is a little 1, positive 1, this is a minus 1, and a minus 1, and a minus 1. So that's where we get our x minus 3 times our 2x plus 1. So that's where that comes from. So now we think to ourselves, okay, so x times x, this rectangle times this rectangle, is going to give me a big square that would be x squared, and of course would be shaded in, because it would be positive, as well as down here we would also get an x squared, x times x, which would be another x squared, again all shaded in because it would be positive. Now x times 1 is just going to give us a 1x, all nicely shaded in down here. Minus 1 times x is going to give us a negative x. Minus 1 times x is going to give us a negative x. And minus 1 times x is going to give us a negative x. Whoops. And down here, same thing. None of these being shaded because it's our lighter color representing negative values. And then negative 1 times negative 1 times positive 1 is going to be negative, negative, and a negative. So these technically, actually maybe I'll go over this with x squared, negative x, negative x, negative x, here as well. And then down here, these are minus 1, minus 1, minus 1. And this would be a positive, oops, x. So there's our multiplication of the binomials using algebra tiles. And once we've got that multiplied out, we simply add up all the things we have. Well, we have two of these, and I'll check in I'll change colors. I'll change to a nice blue color here. This is an x squared, this is an x squared, so we have 2x squareds. We have one positive x plus x. We have 6, 1, 2, 3, 4, 5, 6 negative x's. And 1, 2, 3, minus 3. Now you could write this out as 2x squared plus x plus 6 negatives plus 3 negatives. But when you simplified this and this, you'd get 2x squared plus x minus 6x minus 3 anyway. So that's why those are minuses and not negatives. So it's already been simplified. I kind of did it in my head. Now all I have to do is combine like terms. X minus 6x is going to be 2x squared minus 5x minus 3. Now you have to use algebra tiles every now and then. They do show up on test questions, they show up on quiz questions, they show up on in your textbook questions, and some questions do ask you to draw it out. You should get comfortable with them. I wouldn't expect that you'd have to draw out a ton of them at all, so just make sure that you're kind of comfortable with how they work. Now of course you're not always going to have algebra tiles to play with, and you can very simply take this binomial and use distributive property, or in this case, because it's a binomial times a binomial, just simply use FOIL and multiply it out. So if I were to use the distributive property, dp, distributive property, then I would simply say x minus 3 times 2x plus 1, and I would rewrite this as x times 2x plus 1 minus 3 times 2x plus 1. This would be x times 2x is 2x squared. X times 1 is x. Minus 3 times 2x is going to be minus 6x. And minus 3 times 1 is going to be minus 3. Combine your like terms again. 2x squared minus 5x minus 3. You see you get the exact same answer. And of course, just because I can, using FOIL, I'm going to go x minus 3 times 2x plus 1. And I'm going to say, okay, first it's going to be x times 2x. Outside, x times 1. Inside, minus 3 times 2x. And last, minus 3 times 1 to give me 2x squared plus x minus 6x minus 3. And again, combining my like terms. 2x squared minus 5x minus 3. Using algebra tiles, using distributive property, using FOIL, all to expand and simplify a binomial times a binomial.